Example number 4. Find the volume of the solid obtained by rotating about the y-axis. The region bounded by y is equal to e to the power of negative x squared and y is equal to 0 from 0 to 1. In this problem, the cylindrical shell is rotating in y-axis, so we will be using this formula in finding the volume of the solid. V is equal to the integral from a to b, 2 pi rh dx. Since we already have the interval, all we need to do is substitute all the values to the formula. V is equal to the interval from 0 to 1, 2 pi. The radius is x, and the height is e to the power of negative x squared dx. So we will use u substitution. Let u is equal to negative x squared, du is equal to negative 2x dx, or dx is equal to negative 1/2 x du. So take the constant out, 2 pi times the integration of, since we use the u substitution, the interval will change also. So if x is equal to 0, we have u is equal to 0. And if x is equal to 1, the u will become u minus 1 squared is equal to negative 1. So 0, negative 1, x times e to the power of u, and dx is equal to this 1, negative 1/2 x du. Since b is always greater than a, we need to rearrange the interval. And in order to make it correct, we need to multiply it by negative. Negative times the interval from negative 1 to 0, x times e to the power of u. So we have x eu times negative 1/2 x du. We have x eu to x negative x du. Cancel, cancel. So we have now negative eu power of 2 du. So we have now eu negative e to the power of u over 2 du. Take the constant out again. Negative times negative 1/2 times the interval from negative 1 to 0, e to the power of u du. Negative times negative is positive. So we have positive 1/2. Positive 1/2 times 2 pi is equal to pi times the antiderivative of eu. The antiderivative of eu is eu from negative 1 to 0. Pi e to the power of 0 minus e to the power of negative 1. So we have now pi times 1 minus 1 over e is equal to, or approximately equal to, 1.99 cubic unit.